This is the first episode of Math in the Bubble for Year 12s. So today I'm just going to go through some of the problems that I set for you over the lockdown break, just to get us started. And so we'll jump into it. So I wanted to do solving rational expressions, which is rational basically means like a fraction. It's a ratio, rational, that's what that means, that word rational, in terms of what that is. So they start off quite basic, and then they get a little bit more complicated. We have to factorize to get our cancelling out. So let's start with this one. So generally, when you're given something like this, something is going to cancel out on the top and bottom. So to do that, usually you're going to have, pretty much every time, you're going to have to factorize your equation either on the top or on the bottom or both, and that will allow you to cancel out something. Okay, so can't really do anything with the top, but the bottom, we can actually pull a factor of 3 out of both 3x and negative 9. So that would look like this. So I'm just going to leave the x minus 3 unfactorized at the top, and then we can pull a factor of 3 out, 3 times x, and then pull a 3 out of negative 9, we're going to get negative 3. So actually you can pull a factor out of the top. You can always pull a 1 out. So that'll help us with our final answer, because if we've got an x minus 3 bracket on the top and an x minus 3 bracket on the bottom, then those two will cancel each other out. So that'll leave us with our final answer, which is going to just be 1/3. It's what's left over, the 1 and the 3. Alright, let's move on. Hopefully it gets a bit harder than this. Alright. Okay, this one. Now this one isn't actually too hard, but sometimes it's a little bit hard to spot what you should do. Now, you can always pull a factor of 1 out of any set of numbers, but you can also always pull a factor of negative 1 out. So let's do that with the top. So if we pulled a factor of negative 1 out of the top line, we would get negative 1 plus x over x minus 1. Now, believe it or not, if we moved these two around, we wouldn't actually have changed anything. We would have just put them in a different order inside the bracket. They still add to the same thing. So let's do that. So we got negative 1 x minus 1 over x minus 1, and then we may as well put that in a bracket because we know that's what's going to cancel out. So that x on the top, I just moved it to that side, and the minus 1, I put it on the other side. So that allowed us to cancel this bracket with this bracket. So if you got a bracket that's the same as a bracket on the bottom as it is on the top, then they cancel each other out. So our final answer is just what's left over, which is negative 1. Right. Question 11. So for this one, you sort of need to be able to recognize this form of quadratic. This is where there's no, so usually a quadratic has a middle term, but when there isn't a middle term and the last bit is a square number, then essentially you can just use this identity. 5x minus 5x plus 5. So the minus 5 and the 5, they multiply to make the minus 25, and it just so happens when you've got a plus and a minus that are equal, then this term in the middle ends up being 0x, so it just doesn't get included. So you only have your ax term and your c. So that's factorized our top. Our bottom is an x plus 5. So when we're cancelling, we look for what's similar. So we've got x plus 5 on the top and we've got an x plus 5 on the bottom, so those are the two brackets which will get eliminated. So then we are left with x minus 5. Technically you don't even need those brackets, so x minus 5 is fine. Alright, number 14. So this is the same as earlier. We're going to get an x plus 1 on the top and an x minus 1 on the bottom, and this is like question 5. That was like question 11. So we can actually pull a factor of -1 out of this to, if we pull a factor of -1 out of the bottom term, then we're just left with x, and we pull a -1 out of a positive 1, we get a -1. Okay, so that leaves us with our cancelling of x minus 1 and x minus 1. So we've got x plus 1 divided by -1, which can be simplified. So x plus 1 divided by -1, which is equal to -x minus 1. That must have been a pretty mind-blowing thing that I just solved. I just saw your little emoji things. Okay, question 19, racing through them. So in this question we have just two regular quadratics that you would solve with factors of the last term add to the middle term. So factors are -15, we're going to get that add to -2, so we've got -5 times +3, and then -5 and +3, they add to -2. They multiply to -15. So that will mean that those are just basically our factors inside our brackets. -5 and +3. Okay, and then for the bottom one, we have the factors of -3 that add to +2. So I'm thinking that it'll be 3 times -1, and then 3 plus -1 adds to +2. So on the bottom we're going to get x plus 3, x not plus, I'll just undo it, minus 1. Okay, so in this situation, our x plus 3 cancels out on the top and bottom, so we are just left with x minus 5 and x minus 1, and they can't be, they won't cancel out any further. That's as good as it gets. So x minus 5, x minus 1 is our final answer. Alright, moving on to the next one. Okay, this one's a bit different. We just don't have x's anymore, we've got a's and b's. So how do we approach this one? Let's have a look. So we don't have a quadratic here, we've got a big jumble of letters. So what we want to do is try and pull the biggest factor out of both of these top two terms. So first we look at the 6. What's the biggest number we can pull out of that? We can pull out a well, we can pull a 6 out of both the 6 and the 12. So pull that out. We can pull a squared out of both terms, and we can pull a b out of both terms. But we can't pull two b's out because over here there's yeah. So what does that leave us with? Okay. We have got left over in the 6 a squared b squared term, we have only got one b left over, and over on the 12 we need a 2 to make up the 12 because we've pulled out only a 6. And what else? We have just one a left over, so b minus 2a. Now on the bottom, just looking at these two terms now, the biggest factor we can pull out of both of them in the numbers is a 3. 3 will come out of 3 and negative 6. Both terms have got a minimum of 1a, and both terms have got a minimum of 1b. So once that's all done, we are going to get same as above, b minus 2a, which means that those two sets of brackets will cancel out, and we're just left with this to simplify now, which we can do a little bit of that b and that b will cancel out, and then that a will cancel out one of those two a's, so we've still got one a left on the top, and 6 divided by 3 is 2. So our final answer is 2a.